So this talk will be in English. Sorry about that. Sorry about my accent and everything. We'll be speaking about unicorns because I once said that any slide deck without at least one unicorn is a bad one. You will find a lot of unicorns here, so I think that's a great one. We will talk about the CAP theorem, but as I said earlier, we shouldn't talk about the CAP theorem, so I will talk about it to say that we shouldn't talk about it. And we'll see the new theorems that should be used instead. First, a small word about me. I'm not a developer myself. I don't consider myself as a developer. My name is Laetitia Avrot. I'm a Field CTO for Enterprise DB. You might not know that company, but it's a company that contributes the most to Postgres. We are responsible of 30% of last Postgres release code. I'm myself a recognized Postgres contributor, and I'm also the treasurer for PostgreSQL Europe and the co-founder of Postgres Women. And what more can I say? You can find me on Fastodon. And this is my blog, where I try to blog only about Postgres. And also where you will find all the slides and when there are videos of all the talk I gave since 2018. And found out there are a lot now. And I first encountered Postgres back in 2007 when I was working on a geoportal for Worldline. Oh, and also I'm responsible for that. If you don't know that website, it's my little baby, I love it. It's a website that will give you a tip to use PSQL. PSQL is the command line tool for Postgres, the only official client, SQL client for Postgres. And I found out that people didn't know how amazing it was. So instead of giving you the whole documentation to read, I break that into small tips. When you go there, it will find a tip at random, and you can click to have another one, and so on. Okay, about my slides. If you've already been to one of my talks, you know that I don't like having bullet points on my slides. Because when I do, people read them and don't listen to me. And as a mom, it's infuriating not to be listened to. So you won't find any bullet points on my slides, only images. Normally there should be jokes in the background images, just so you can stay focused. But if for any reason you need bullet points, you will find the slides with bullet points. Don't worry, there are still the jokes with the background images. You won't miss that. But should you need it, feel free to use the QR code. And at the end, I will try to describe some blueprint architecture. And you know how architectures can be very messy. So I encourage you to scan this QR code so that at the end you will have another screen with the architecture because maybe it will be easier to read. So, chasing unicorns. I'm the kind of people that come into a meeting with a customer. The customer says, we want that. I say, that's not possible. We have a mathematical theorem that says it's not possible. It does not work that well. That's not how you have to do it. Well, that was how I was before, but I changed because obviously people don't mean the same thing when they say they want it all. And so first we'll talk about data loss and downtime, because also I have customers when I go there and ask them about how much data loss they can afford, they don't know. Or how much downtime they can afford, they don't know either. I had this very funny meeting with a customer once. He said me he wants 0 downtime. Then I asked him how much downtime he had last time he upgraded his app. 3 days. I said, okay, so maybe we can change this 0 into something else. So first, 0 data loss does not exist. So let's, this is a Star Wars reference. Let's say that the Death Star comes into the Earth and does to the Earth what it does to Alderaan. everyone will lose data. And we wouldn't care, because we would be dead. Okay, so what I mean is, unless you send your data to another planet and so on, the probability, asking for 0 probability to lose your data is not doable mathematically. Actually, I found out that when people say they want 0 data loss, they don't mean 0. They mean they want a 0 data loss in case of that failure scenario. For example, should their data center burn down, they want a 0 data loss. Or should they have a problem with their storage, they don't want to lose data, things like that. So what I try to explain to my customer is, okay, in what scenario do you want to be protected against? Where can you afford to lose data? Depending on the probability the scenario happens, then it can be affordable or not. So that's how I work with my customer. And then we have the downtime. So we agree that if we want 100% of availability, it means 0 load failure. And when I say 0, I'm an IT people, so I mean even 0 microsecond. Because I'm an IT people, and when I say 0, I mean the mathematical 0. And I found out that the people I was talking to, when they say 0, they don't mean 0. They mean something else. Maybe 0.1 means 0 for them. Because 0 is an approximation. It's not the strict 0. So I found out that as IT people and scientists, we had a communication problem with normal people, if we can call them that. So we have to discuss that with them. Normally, we do categorize the availability needs into 9s. So this is 5 9s. 5 9s means that you can't afford more than 5 minutes of disruption yearly, which is not a lot. 4 9s, 52 minutes. That's still not a lot. And 3 nights is over 8 hours. So if you look at what Facebook did that horrible year in 2021, they didn't even reach 3 nights. So if Facebook can afford more than 9 hours of disruption time in a year, maybe your little app that's just showing the menu of your restaurant can afford such a downtime. And also I have this funny customer say, oh, I'm okay with only 5 9s during daytime. Actually, it's worse, because it means that you can't afford more than 3 minutes disruption during the day. So it's worse than 5 9s. And it's very difficult to achieve on the database world. I know that if you have a stateless application, that's easy. But I'm working with a relational database with things very complicated like transaction, distributing transaction, and so on. That's difficult, but doable. So the first lesson we need to understand is anything can break. And I love the face of the guy on the right on the screen. So when you're running a database, it's never running by itself. So here it's the minimal level of layers we can have. We can have way more than that. If we're using VMs, if we're using containers, we will have other layers on top of that. But let's say we just have hardware, OS, and database. When it's down, maybe the culprit is not the database. Maybe it's the OS. Maybe it's the hardware. Most of the time it's the hardware. But if we're on that stage. But having an instance of a database running without nothing doing anything with it, that's not how we do it. Most of the time we have an application that will look into the database, because the database by itself is not something that we want to distribute to users. So on top of that, we will have another the network, and then the application itself running on, and again, it's only the minimal layer, number of layers, but there is, again, hardware, OS, and application. And on top of that, most of the time, we also have a network with clients. So when I say that anything can break, it's because when I was an on-call DBA, and I was called at 2 a.m., because, you know, it's always at 2 a.m., there's something magical. I was called because they said the database was done. Most of the time, it was not done. The problem was not the database. But I don't know why. It's always the database that is blamed. So if you have DBAs in your companies, I encourage you to do that. On the first Friday of July, it's a DBA Appreciation Day. I encourage you to go to your DBA and say thank you. Because if your database is running smoothly, it's because they are doing an incredibly job, an incredibly amazing job, and you don't know it. But what the interactions that DBAs have with people, it's when it's down. People yelling at them, people saying, what did you do, and things like that. Was actually, they are doing a really good job most of the time. And most of the time, the database is not the culprit. That's something I learned when being on call. So let's go to the CAP theorem. So normally, you know that one. It's pretty well known. It was first announced in 1998, something like that. It was formally proven in 2000 by Brewer. So it says that when designing distributed web services, there are three properties that are commonly desired: consistency, availability, and partition tolerance. So the theorem states that it is impossible to achieve all three. Most of the time you see them represented there and saying that that zone here is forbidden. So let's take back and look at what they mean. Consistency. Consistency means that each node will see the last, and I added committed, version of the data, because we don't want to read the data that are not committed yet. So it means that when I change something, I want, and I query it right after, I want the new version. I don't want an obsolete version of my data. Availability, normally we understand what it means. The system will always answer something different than an error message. And network partitioning, the network will be allowed to lose arbitrarily many messages, and it's important with the many messages, sent from one node to another without altering the system answers. So the system will keep going even though there is a network partition. So the CAP theorem, as we say, is, as I said already, is always represented with these three circles. And I don't like it at all. What I like is rubber bands. So imagine that you have three poles: consistency, availability, and network partitioning. And you have a rubber band, but your rubber band, even if you extend it, is too short to reach the three poles. So what you can do is put your rubber band around two poles and stretch to the third one. Or you can come from the middle of your triangle and extend your rubber band to the three poles. In my opinion, that's a more accurate way to represent the CAP theorem. I've read people saying RDBMS are CA, meaning they favor consistency and availability above network partitioning, meaning it's a central system. Actually, that's true and false. RDBMS in single node configuration are CA, that's true. But who does run an RDBMS on a single node nowadays? Do you? Yes, 1 out of 3, 4. So Yeah, normally we don't do that. We always have at least one replication. So if you have an asynchronous replication, then you will sacrifice your consistency, because if you read on this asynchronous replication, then you might not get the latest version of the data. But you say, I can use a synchronous replication. That way, I'm sure that I will have the latest version of the data. That's not true. If you use a synchronous replication, it means that the standby will have to acknowledge a change before before the primary sends the acknowledge of the commit to the client. It means that there's a short time where you can query the standby, have the data that is not committed on the primary. Even though it's a very short time. It means that RDBMS with synchronous replication are neither CP, neither AP, because also if we stop the standby, then the primary will wait indefinitely for the standby to answer back, so that we won't be able to write. So that's a disruption, that's downtime. So we are neither CP, neither AP in that configuration. It does not make it bad. It can be totally legit and usable for your use case. It's just that you have to know that. So let's go to the theorem we should be using instead of the CAP theorem. It's called the Parkelk theorem. And the first part shouldn't be that strange because it's a CAP theorem. In case of network partitioning, that's P, in a distributed computer system, one has to choose between availability, the E, and consistency, C. So that's a CAP theorem, nothing new. But else, E, even when the system is running normally in the absence of partitions, one has to choose between latency, L, and consistency, C. So this theorem was announced in 2010 and demonstrated formally in 2018. But when you look at the CAP theorem, you find out actually that the latency is missing. And the latency is a very important part. Because nowadays, who can afford to wait more than 2 seconds for a query to complete? No one. You can? Good for you. So what is latency? Latency is the amount of time the system needs to answer when it's smaller than a request timeout. It's difficult to say how much time it means because it will depend on your context. If you look at what Amazon did, so Amazon has this very important problem that people put things into the basket, and if it takes more than 250 milliseconds to display the basket before people can purchase things, they won't purchase because they will have the time to think and find out that they don't need all this stuff. So they decided that each page should be displayed in less than 250 milliseconds. If you're using a transactional system, I normally ask my customers to consider a slow query that any query that is over 250 milliseconds. Because on top of that, you will have the application to process the data, display it, and so on. So it's already more than 250. If you have a decisional system, then you can go up to 1 second. 15 years ago, we could afford 5 seconds in decisional. We can't anymore. People want their result right now. So if we understand correctly this theorem, it says that after we've chosen between if we wanted to favor consistency or availability, we will have a latency problem. And it totally makes sense because if you want to be protected against network partition, then you will have to create replicas. And these replicas, if you want them to be synchronous, you will have to add latency because you will have to have the network round trip and the database acknowledging the changes and so on. So that it totally makes sense. But that's the new theorem we should be using instead of the cap theorem, because putting the latency out of the equation is not a luxury we can have. One thing funny about availability. I said I had a customer who could afford 3 days without a problem. I also had a customer who called my boss saying, "What the hell happened? We had a disruption of 6 seconds. That's not possible." Because it really depends on your context. And so we had to change the architecture to make sure they had something that was better for them. So I will give you some blueprints of typical architectures I delivered at customers, depending on their need. Of course, what I say with Postgres is you can do everything, but do you really want something very complex that will be difficult to maintain, difficult to operate on a day-to-day basis? So what I try to do is implying the KISS principle, keep it simple and stupid, because the more layer you will add, the more complexity you will add, the more risk of failure you will add, which is not the point because you're trying to be protected against failure. So there is some balance points you will have to find here. And my blueprints are only example. You can do other things. It's something that works very great with my customers. So first, just some vocabulary. You know that we totally banned the master-slave denomination because it's not a good analogy. And we know in pedagogy that if you use a bad image, a bad analogy, it does not help to understand how it works. So, and the problem with the master-slave terminology was that when a slave dies, it's pretty rare that we take, when a master dies, it's pretty rare that we take a slave to take the place of the master. It happens in 13th century in India, but that's very, very rare. I will go with one of the terminology here. It's based on a hive. So first, in a hive, you have one queen. The queen is the database server who can read and write. And there's only one in a hive if you want the hive to operate normally. Then we have princesses. Princesses are database servers who are waiting for the queen to fail to take over. Also, we have workers. The workers in this analogy will be the database servers that will serve read queries. What I love with this analogy is that it explains my customers that you can't have a standby that will at the time give you read query, delivers you read queries and be a good point to fail over to. Because you can try to have a princess working, but it does not work that well. And you can have a worker trying to become a princess, but it won't work that well either. Okay, data loss. Are you familiar with RPO, RTO terminology? Okay, so RPO is recovery point objective, where it means how much data loss can you afford. And when I say afford, it can go up to how much data loss can you afford without your company being bankrupt. It totally depends on your context, but let's say that if you can afford more than 50 minutes of data loss, then you will be fine with physical backups and wall archiving on your database. If you can afford between 1 minute and 15 minutes, then you will have to go with a physical backup, wall archiving, and an asynchronous process. why still backup? Because you don't know what can happen. And for example, a logical corruption, saying someone deleted something into a table without the word clause. It happened in production to me. No, I didn't do the mistake, I had to fix it. Then it will be propagated to your asynchronous princess. Because normally the lag between the queen and the princess, if they are on the same data center, on the same network, is 200 milliseconds. Given the princess has enough CPU, memory, and so on to apply the changes. So between 1 minute and 15 minutes should be okay. If you can't afford more than 200 milliseconds of data loss, then we suggest to go with synchronous princess. And if the problem I said with synchronous princess is you will have, if your princess is done, then the queen won't be able to write, which might be an issue. So you can add another princess and say in the configurations that you will need a quorum of 1 out of the 2 princesses to acknowledge the change. So that should one standby fail, you will still be able to write into your queen. And again, because I know that I need to say things 3 times for you to keep that in mind, an RPO of 0, and I'm talking about the mathematical 0, is not possible. Because even though you have 5 data centers, if these 5 data centers are crushed, then you will lose data. And we know with OVH experience that a fire can propagate through data centers. So RTO, recovery time objective. It's the time it will take to recover. It's a time it will take to have your database instance up and running again after a disaster. Well, disaster or simple problem. So if you can afford more than 1 day, normally, depending on your the amount of time you need to restore, you will just need a physical backup and while archiving. I didn't say it because it's obvious to me, but a physical backup without testing is not a backup. It's called a Schrodinger's backup, and you don't want to see if it's alive or dead. So you should be fine, but just make sure when you test your backups that the time you need to restore is okay. Just so you know, if you're looking for a physical backup tool for Postgres, don't look far. PG Backrest is the one you need. It's open source, it's great, it's the most advanced backup tool, in my opinion, in the Postgres community at the moment. So don't look at anything exotic, don't try to use PG-based backup, which should be PG clone MyDB, because that's what it does. It's only a clone tool. Use PG Backrest, and it has this great feature that can do a delta when it will restore only the changes the files that changed. That can really make you restore faster. Oh, yeah. So the question is, can I explain WAL? So WAL is for wall ahead, write ahead log. It's the redo logs in Oracle. In Postgres, it's write ahead log. When you do a change in the database, before flushing, you won't flush it in disk immediately because it's not a sequential file, so it's too bad for performance. But you don't want to send the commit acknowledgements without having it somewhere in disk, because if it's only in memory, if it crashes, you will lose it. So we send it to a sequential file called write ahead log, where every change is logged there. And if it crashes, then we will look at the file and reply. And that's also on that depends streaming physical replication. We send the files, well, streaming physical replication sends the blocks when they're written. RTO recovery time objective, if you can afford 13 each minutes and you have a great team and your VPN is not down, because at 2 a.m. I don't know why the VPN is down when you want to connect, then a princess with a manual failover should be enough. 30 minutes is with a very well-trained team. You won't be able to do that if the people don't know what they're doing, are looking for the procedures and so on. Or if the team that is doing the alert takes some time to find out who is on call and so on. That's really the minimal time, and it's very difficult to achieve, but it can be done. When I say manual failover, it's you have to issue commands to do the failover. But if you can't afford that much time, then if it's between 5 and 30 minutes, then you will rely on automatic failover. So you will install a tool that will do that for you. Also, I really strongly suggest using automatic failover, because these tools are also responsible to make sure there is no split brain situation in your database setup. A split brain situation is when you have two queens. You know what happens when you have two queens in a hive? One is taking half of the workers and taking it away. Two queens in a database setup means data loss. That's not something you want. Obviously, because you're trying to protect it. So the tool will make sure that it does not happen by shutting down the, depending on the tool, the way of doing it is different, but I love what we do with one of the tools is we create a failed configuration file so that Postgres can start. Of course, should you remove the failed configuration style, then Postgres can start. And then, if you want to rely, so that's why we have 5 minutes, because you can fail over very quickly with Postgres, since less than 30 seconds. The problem is you have to make sure that it's a real failure. So there are several timeouts involved that you can tune depending on the quality of your network. You don't want to fail over too often, because each time it's a risk, and each time it means you will have to rebuild your queen, your former queen, as a princess. So that's in French, sorry. So if you can't afford more than 1 minute, 30 seconds of availability of downtime, then we recommend going with a multi-queen system. There is only one solution to that in the Postgres world. It's called Postgres Distributed. It's created by my company, and it's not open source, it's closed source, but it's written by the same people who wrote the logical replication into Postgres. So it's very close to the implementation of logical replication. It's a fork of Postgres, but we maintain it up to date because the same people are working on both sides. Again, if you want zero downtime, and I mean the mathematical zero, it's not possible. Just to make sure you have it. Okay, so this is a very standard architecture that will work with most people. The good thing is, normally it should fit in most budgets, because we know that the problem is money when you want something. It can be implemented on 1 or 2 data centers. And most of the time, the recovery time objective is around 30 minutes. And we have a recovery point objective around 200 milliseconds, given these 2 hosts are on the same data center, on the same network. Also, check that I used colors here, because I've seen so many customers calling that primary, secondary, and when they're running at the secondary, they want to go back to the primary. Actually, if you're relying on automatic failover, you shouldn't worry which node is running at the moment. That's not your problem. So I love using colors because you should be as comfortable running on one node or the other. That's the whole point of having a real disaster recovery system. So let's see how it works in details. So we have a simple asynchronous streaming replication, meaning that the blocks are sent directly from the queen to the princess. It can be spread over 2 data centers. Depending on your network, it will add more latency into your standby, par quelques theorem. And also, very important, as from the Postgres architecture, Postgres is, each time you will create a connection to Postgres, you will fork the postmaster process, which is not a problem most of the time, but if you want to create a lot of connections for small queries, then the problem won't be Postgres, the problem will be the operating system won't be able to keep up. So to avoid that, we strongly recommend you to use a connection pooler. And the connection pooler should be on the application host, so that should the connection pooler fail, should the host fail, it's not a problem. And also it's a stateless application, so it makes sense to have it there. So the connection pooler will maintain a certain number of connections and will reuse them so that the operating system on the host of the primary won't struggle with all these forks being created and removed. Then we have monitoring tools. Here, monitoring agents running. We have a monitoring here that uses its own database, because that's how tools work normally. And I have a backup tool here that will restore once a day, do a full backup once a day. Maybe it's a full backup once a week, and you will have differential backup or incremental backup once a day. It depends on what you want to do. And we have wall archiving. When you do a physical backup, you are copying inconsistent file, because we don't know when the database will flush data into the data files. So that you will need to reapply all the changes between the beginning of your backup and the end of your backup. So if you just take the backup without the wall file, if you're not using a great backup tool, which can happen, and it does not take the backup, the wall file, you won't be able to restore. Normally you should see it here. And the last thing I want you to be aware of, configuration files versioning. We have a huge configuration file for Postgres. I strongly recommend you to clean it up. First, remove all comments. You don't need that in production. Second, remove all settings that will set the value to the default value. You don't need it. And make sure that your configuration settings will be available on only one terminal screen, so that people working at 2 AM because there's a problem will be able to see everything. If you can't, you can use, you can include a directory so that you can have separate files depending on the kind of settings you're doing. And what I strongly recommend my customers to do is having a Git here with their configuration file so that they can version it and add a commit message explaining why they changed the configuration. Because that's important to know. Because we have such a turnover in IT that maybe in 5 years, the person who did that is not there. Or maybe they won't remember what they changed. And when you want to question that change, when you want to change it again, you have to understand why it was changed. Okay, so this one is a little more complicated, but it will be easy. So first thing, this will work with medical grade data. It's a state application for all medical grade data, all let's say health files for all the population of the state. The state is the side of Belgium. They want hybrid availability. because they don't want somebody dying because they didn't know they had some allergy or things like that. So they need to have all their reads. Each read should be in less than 1 second for a file. And a file meant several queries. And they wanted to lower down data loss risk because it's very sensible data. They don't want to lose them. So let's see what we did. First, we have one queen here, a princess, with an automatic failover tool here. And we have a synchronous replication going from there and there. They had two kinds of applications. Third-party applications on which they had no, they couldn't change, so that they will go with read and write queries through the connection pooler that is multiplexed to make sure that if one fails, that we're okay. Through a VIP, because we're using so VIP means virtual IP, because we have a failover tool taking care of it. And their own applications where they were able to use two data sources using JDBC drivers. So they will have one data source for write queries and another one for read queries, which is redirect to asynchronous replications. So they decided to sacrifice a little their consistency to favor their read speed. And they are able to create as much read standbys as they want. And then, because it was only on one data center, they wanted to double it. Oops. Sorry, before that. Here we have a small host with the same configuration, files versioning, the backup tool that will periodically test the backup, and it will be what we call the cold standby, meaning that in case there is a very absolute disaster, they can query directly that one. They can start it up, add the whole files, and have some degraded version of the application that will use that database. So, if we double the data center, so again we have the blue denomination here and the green here. We added two princesses here, and we have a quorum of 1. So in a normal world, this one should be the one that is synchronous, and this two will be asynchronous, because this one should be faster as it's on the same data center. But should that one fail, then one of these two, the fastest, will answer. And we have also the same, so the applications are still there. We have the read. The application will work simultaneously on both data centers. And we have a duplication of the backup here, just to make sure that we can operate on only one data center should we need it. And then we added what we call all the rest. So, as you know, a human person can live a long life and can have a very long medical record. We decided that to have less data in the Queen database, we will do what we call online archiving. Online archiving is we will export some data here, some old data. So, for example, data that are more than 5 years old will be stuck here, but we will be use here what we call foreign data wrappers in Postgres to query them. It will be a little slower because we have to address the database somewhere else, but you can join everything, you can operate the table as if it was here, so that the application does not have to change. The other thing we did is, once a person is dead, having their medical record fast is not that important. So we decided that 1 year after the person's dead, then we will extract the data and put them on files that can be restored on demand and can be checked using the foreign data wrapper here on the primary database. And the last thing, of course, monitoring. I didn't add the monitoring agent everywhere because but it's still there. It's just that it was a lot in my drawing. So this is the complete architecture we went with. Again, it might be funny that I said keep it simple and stupid when you see that. But considering the constraints and the goals we were trying to achieve, this is the simplest architecture we can come up. And the last one, it's a bank. They have a lot of transactions and they can't afford 6 seconds of disruption of downtime. So that's why we decided to go with Postgres distributed. So we will see that in detail. So you see here, it's written BDR. BDR is a former name for Postgres distributed. BDR is for bi-directional replication. So we had a lot of rights in this, but you don't think of Postgres distributed as a solution to spread the writes on several nodes, because each node will, at the end, have all the data. So each node will have to write everything, whatever happens. It's more for very, very high availability. So here we have what we call the lead master, because the problem with bidirectional replication is we have two kinds of masters. First one, lead masters, is where the application sends write and read. And we have the shadow masters. It's the kind of princess for bidirectional replication. Normally, you shouldn't read and write there, but they're ready to take over smoothly when the lead master fails. Also, as it's a distributed system, you know that you can't have an even number of nodes in a system, because there are some use cases where the system can't automatically find out who is failing, what's the problem. For example, should you have a disruption between two data centers? How do you decide what to do? That's why we added a witness here on another data center. The witness does not hold data. It's just set to understand, to answer the queries. And for example, if you have a disruption, a network disruption between these two, this one will be able to say to the others that it's still alive. So, on top of that, we added logical replication here. Why? If you add 2 nodes on the BDR side, on the Postgres distributed, it means you will have a factorial 6 number of communication channels between the database. That's a lot. So to avoid that, to avoid too many network traffic and so on, we simply create a logical standby. This logical standby can be added into a PGD setup by just switching a command. So that should that one fail, you have a replacement here. Why do we do that? Because each time you want to create a logical standby, you will have to copy over all your data. And it can take some time, depending on your data. And then we added a connection pooler and handshake proxy, so that the application can smoothly connect to the right node without having to ask themselves what is the right node. And it can also, it will normally connect to the lead master, but it can also connect to the shadow master if needed, depending on handshake proxy. And after that, you add backups, because of course you need them. And at the end of my talk, so I just want you to remember some things. The database is not the only element that can fail. You are not Google. Well, probably you are not Google, So unless you are in a very specific area, you should be able to afford some data loss or some downtime. And if you can't, then it will be very costly to reach a more complicated architecture. And it will also be very difficult to maintain, meaning the risk of error will be higher. Figure out what your RTO and RPOs are and make sure they are written somewhere so that you can rely on it. And the last thing I'd like to add is I'd like to thank my friend Gershon, who created that sentence when I was battling with a customer who wanted 0 data loss and 5 nines. And she said unicorns are more real than 0 data loss and 5 nines availability.